Okay, so next thing would be to hold out the long-awaited spotlight here. Yay, the target spotlight. Here we go. Most useful of all is a spotlight because, for one, now we have control over the direction of the light itself. It's not going backwards, not going to the sides. It's just happening in the cone. You can see the cone, right? This is spotlight, just like any spotlight in the world would behave. And second is the range, the area. Okay. And third, of course, same thing though, intensity. Okay, so we also have the attenuation, but just one more thing is that we have like a cone to control a better control of the direction. But remember that though, for a spotlight, it's still different from an area light because all the light rays is coming from a single point in a spotlight. But in an area light, as we progress into the next tutorial, is coming from a bunch of many pixel points from a surface of an area. No matter how big or small that area is, it's still different from a point or from an area. It's the shadow that you see. So now I'm just going to, well, this is a way not done and this is just not the proper setup, but I just want you to take note of how a spotlight works. Okay, how a spotlight works. So I could turn off just to study, right? We always want to isolate factors. Now you're seeing nothing. Well, but then is that light even on, or you would say, well, maybe the power of it is too small? Okay, let me put 5. That has to be a lot then. That's way a lot. But we still don't see anything from the front. But you can see this is really intense light coming from a cone and so sharp the edge and really shining down. Exactly what I'm trying to achieve is get a rim here. Get some light from the back, so then once I have all the key light and fill lights back, I have like a white rim. Remember when people shoot movies or do stage lightings on the actors or the characters, they always prefer that they have a rim, side light or top or kicker. That's what they call these terms, and to kind of outline the character so it stands and pops like from the background, so it's not like stuck to the background and gets a sense of depth. So this is some tricks that we use. Only problem is, well, in a gallery sometimes you see this cone or this hot spot on the floor. That's fine, but now I'm trying to play like low profile. I want the rim, something I really want to take a hold of, but then I never wanted so obvious a spotlight so that he's not like we're not in a rock concert, right? So what we do is still use the attenuation, pretty much the same operations, same characters, parameters, in this rollout menu of the omelette light, except one thing is the spotlight parameters and light cone. Okay, light cone here. Well, we can change it into rectangle. I don't see the necessity of it, but these two things is the most important things about the settings of a spotlight. You really have to pay attention. Now I am going about defining them. So you have two numbers, and remember the lower numbers fall off. I would call it the outer cone. So, and the hot spot, the top number is the inner cone. So the difference between them has to be at least 2 units. Well, God knows what units these are. Imaginary lighting units. At least 2 difference between them. So can you make this bigger? Yes, without changing the smaller number. But can you make it smaller? No, unless you decrease that too. So now, what happens if I make the outer, the bigger one bigger. Well, this is a little hard to say to understand, but bear with me. The little one littler, the little one smaller, the bigger one bigger. What would give you is a longer distance between the two cones, and that not only affects the area that you are shining on, but also the calculation, the algorithm of the progression of the drop off, the fall off, as its name. The gradients, this is gradient 100% here, just like attenuation of decay, 100% inside of this smaller cone in strength, in power, 100 total, and then it starts to drop from the smaller cone to the outside, to the larger cones, and then it gets 0 and nothing gets through that. So everything outside is pitch dark. So what we have, if I could say render this one, now you see a softer edge. Can you see that? Right? And actually part of it is not really that burnout or washout, whitewash. So now same idea as in attenuation. Okay, so it's by changing these two numbers. So how large, first of all, how much of the statue you want to cover it with 100% brightness, and then how big or when or where do you want to chop it off, and how soft the edge, how quickly it decays, all comes into play with the two numbers.